Hi friend, this is Ans. You watching Mr. Ans channel on YouTube. In this video, we have types of mechanical waves. The first part of this video, depending upon the direction of displacement of medium with respect to the direction of the propagation of wave itself, mechanical waves may be classified as longitudinal or transverse. Longitudinal waves can be produced on a spring. So first thing is longitudinal waves can be produced on a spring, slinky, placed on a smooth floor or a long bench. If a spring is on a smooth floor or a long bench, we can see the longitudinal waves are producing on the because of spring. Fix one end of the slinky with a rigid support and hold the other end into your hand. If you have a spring, for example, I have this spring, and this last thing is attached with a rigid body, and I am shaking this. So here something is happening. For example, in this picture you can see longitudinal waves on a slinky. So the very first thing we have this board. This is a rigid body which is fixed for a permanent time. This is your hand. In the hand you have this spring. So now you are moving your hand. This is your movement of hand, and this spring is going upside, forward and the backward. So we have to see the direction of the wave. If you are shaking this, and the direction of the wave is going to the forward. Displacement of particles, and these are the particles. You can see these particles, how much displacement they're gonna cover. This is also the second thing in the longitudinal waves. And the compression, how much this part and this part is compressed, and this part is not so much compressed. Okay, so this is refraction. For your information, longitudinal waves move faster through solid than through gases or liquids. Next, if we see a series of disturbances in the form of waves will start moving along the length of the slinky. Such a wave consists of regions called compressions. So we see compressions as disturbances during this phenomenon, where the loops of the spring are close together, alternating with regions called refractions, where the loops are spaced apart. In the region of compression, particles of the mediums are closer together, while in the region of refractions, particles of the medium are spaced apart. You can see there are so much space between in this part, but there is so much enough, not too much. There is a part space between them. So we can see that while compression, the particles are so much compressed. The distance between two consecutive compressions is called wavelength. So the distance between both compressions we have this wavelength. What is wavelength? The distance between two compressions called wavelength. The compressions and refractions move back and forth along the direction of motion of the wave. Such wave is called longitudinal waves. So we can say the compression and refraction move back and forth along the direction of motion of the wave, such as, so if a wave is moving forward and backward during the compression and refraction, this is called longitudinal waves. In longitudinal waves, the particles of the medium move back and forth along the direction of propagation of waves. You can say if this wave is moving in this direction, so the longitudinal waves, particles of this wave of the medium move back and forth to the direction of the wave. So particles moving to and backward during this phenomenon, so longitudinal wave. In the longitudinal waves we see compressions and rarefactions, and between them we have a wavelength. We can produce transverse waves with the help of a slinky. Stretch out a slinky along on a smooth floor with one end fixed. Grabs the other end of the slinky and move it up and quickly. A wave in the form of alternating crust will start traveling toward the fixed one. The crests are the highest points, while the troughs are the lower points. Crust and trough. Higher points are crust and the lower points are trough. You can see these are crust and these are trough. The higher part of the wave is called crust, and the most stretch point, the most compressions, between both compressions we have a wavelength. And where we are not seeing so much space, we have not wavelength, we have rarefaction. So this is our spot, rigid body. This is our hand, we are shaking this. So what is transverse wave? In case of transverse waves, the vibratory motion of the particles of the medium is perpendicular to the direction of propagation of wave. So particles of the medium will be perpendicular to the direction of waves. So this is our transverse wave, where we can see that the particles are moving to the forward side and then coming back. So this phenomena, you can see the transverse waves. So gonna see you in the next video. Until then, goodbye for now.